Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 19, 2025, just yesterday. The headline result is a new state-of-the-art on the OSWorld benchmark, with AutoGLM-4-9B hitting 48.1%, powered by an end-to-end reinforcement learning system that blends API control with direct GUI actions. The paper is titled, ComputerRL, Scaling End-to-End Online Reinforcement Learning for Computer Use Agents. And, as we will see later, the implications for model training are quite significant. Beyond the score, the work introduces a massively parallel desktop simulator and a training recipe called Entropulse that stabilizes long online learning. Building on that, the tweet introduces ComputerRL as a framework for autonomous desktop intelligence, highlighting the API-GUI paradigm that blends programmatic calls with direct interface actions. Engagement looks solid with around 257 likes. Alright, we are looking at a two-panel figure that summarizes performance and training dynamics. The left bar chart shows success rates on OSWorld, where AutoGLM-4-9B reaches 48.1%, with the stacked segments indicating supervised fine-tuning contributions and additional gains from reinforcement learning. The right line plot tracks reward over training steps, and the red Entropulse curve rises faster and plateaus higher than the blue baseline, which signals better learning efficiency and final performance. Together, these visuals link the score gains to more stable, higher reward training. Continuing with the visuals, we are looking at a two-panel summary that ties results to training dynamics. The figure shows success rates on OSWorld at left, where AutoGLM-4-9B tops the chart at 48.1%, which indicates a clear lead over prior agents. On the right, you can see training reward over steps, and the red Entropulse curve climbs faster and finishes higher than the blue baseline, so learning is both more efficient and more stable. Now we are looking at the overview diagram, which lays out how rollout, action choices, environment scale, and online updates connect end-to-end. You can see the left block showing thoughts feeding into two action spaces, GUI actions like click and type, and API calls like highlight or compare, so the agent can choose whichever is more efficient. The center illustrates a controller driving over 1,000 virtual desktops. On the right, the data queue records successful and failed trajectories for training. Along the bottom, the online update loop syncs parameters across actors because training is fully asynchronous. Next, we are looking at the three-stage training diagram, which lays out behavior cloning, the first reinforcement learning phase, and the Entropulse loop. The left panel shows behavior cloning from filtered step data that establishes a reliable base policy. The middle panel depicts rollout collection with step-level rewards and filtering, so useful trajectories feed the next stage. The right panel illustrates alternating supervised fine-tuning with reinforcement learning, which boosts exploration, restores entropy, and yields the final agent model. Now we are looking at Table 2, which breaks results down by domain so we can see where each design helps most. The top block compares GUI only against API-GUI, and you can see large jumps in Office and Professional, which pushes the average from 11.2 to 26.2%. The bottom block steps through training, where behavior cloning sets a 31.9% base, RL Phase 1 lifts it to 42.0%, and the Entropulse plus RL Phase 2 combination reaches 45.8%. Now we are looking at Table 1, which lines up agent models, parameter sizes, and scores on OSWorld and OSWorld Verified. You can see two blocks, proprietary models at the top and open models below, so comparisons stay apples to apples within each group. The standout row is AutoGLM-4-9B, which posts 48.1% on OSWorld and 47.3% on OSWorld Verified, leading the table. Building on earlier charts, this confirms gains translate across both evaluations. We are looking at a two-panel figure that tracks reward on the left and entropy on the right across training steps. The shaded green band marks the Entropulse interval, after which the red series continues higher than the gray series, so the policy achieves better reward. On the right panel, entropy rebounds with the red series, while the gray series keeps drifting down, which signals restored exploration. Together, these curves show that alternating supervised fine-tuning with reinforcement learning recovers entropy and unlocks additional learning. Building on that, two takeaways stand out. Unifying API and GUI actions lets the agent choose precise program calls or flexible screen interactions, and the Entropulse alternation stabilizes long training by restoring exploration. Reinforcement learning here means learning from trial and reward, while behavior cloning copies expert steps. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.